Welcome to this session on data architectures for cloud-native computing. My name is Alvin Richards. I am Field CDO at DataStax. This almost feels like a sort of bad joke you would tell a friend down a pub, but I was talking to the CTO. And the CTO had a super interesting challenge. On one hand, they wanted to be able to ensure that the developers had access to the right cloud services to solve the problem at hand. Maybe it was to use GCP for image processing, AWS for AI and machine learning, Azure for another service. But ultimately, they needed the ability to get the data to the right cloud platform, but to also ensure the consistency of that data, the versioning of that data, the lineage of the data, so that they knew how the data that was derived was being used and where it came from. All of that had to be contained within an environment that the data was secured and ensured the right privacy, the right parts of the data to the right aspects of those services using it. This was going to be the biggest challenge of trying to adapt and evolve a cloud strategy when it started encompassing stateful data. Now, let's set the scene a little bit. All of you know that data is growing. That's no surprise. But many research analysts have been looking at what does cloud and data really mean together. And as you can see from this data from Gartner, they're predicting by 2023, 50% of all data that's been manipulated is going to be done in the cloud. That's a huge seismic shift from even just 2 or 3 years ago, where a very small part of managed data was occurring in the cloud. The analysts are predicting there's going to be an increasing push to not only run stateless processing in the cloud, but to store state and the data for that processing in the cloud to co-join them. So let's start at the beginning. What do we mean by cloud native? Well, cloud native is a software development approach that utilizes cloud computing, that delivers scalable, modern, dynamic applications utilizing both private and public cloud infrastructure. So why is cloud native important? Well, there are two aspects to this. There's two key demographics that you want to think about. First is the developers. Do they have access to the right services in order to solve the problems at hand across those cloud vendors? Going back to my CTO friend story, you know that you want to be able to utilize the best of breed in order to solve the problem for the business in the right way. The operators are our second demographic, right? They have to operate across many clouds. They have to ensure the reliability, the security, the compliance, and many other aspects of those disparate cloud services. And so they need solutions that allow them and enable them to operate freely in those environments in a uniform and consistent way. So that sounds great. You almost certainly are using cloud services right now to develop your applications. So everything's going great. What possible future crisis might you have? So let's just think about what that existing cloud deployment may look like. You may have some stateless services as applications or microservices. They're likely to be going through an API gateway that is doing control flow and some other metering. Behind that, you may have Lambda functions that are executing on those requests to transform them, to modify them, and then underpinning those may be one or more cloud services. They could be cache services, they could be persistent data services, they could be streaming services. Whilst you may have picked one cloud vendor, you may have to combine services from a disparate number of vendors on that cloud platform, because not all of the cloud vendors have all the solutions that you need. You've essentially turned your organization into a service integration business by having to stitch all of these services together. That means the developers have to be sophisticated in their knowledge of how each one of these services works, and then the operators need to manage each one of those disparate services independently. This is a difficult but solvable problem. if you have enough manpower or people power to actually solve it. But you add a second cloud into that, and now those same services may be represented in a different opinionated fashion by your new cloud vendor. What was a key value store may not have the same, or it may have a different API. Some cloud vendors think very verticalized in what a service should do. Others think of it in a more aggregated fashion. So tabular data could be one service in one store, but it could be made up of many different stores in a different vendor. So again, you now have a multiplying factor of the number of APIs the developers have to be knowledgeable about and successful with, and your operators now have to manage across this vastly larger platform and landscape in order to run effectively. This is a huge headache. So to summarize that, what is the problem with a hybrid multi-cloud? You've got multiple developer APIs, multiple operational APIs, multiple vendors, multiple cost models, right? The way that metering works for all of these vendors and how to optimize that is going to change over time. And you have to become the expert on that in order to rationalize your total cost of ownership. So a hybrid multi-cloud strategy is going to entail more risk and going to cause more uncontrolled costs in your cloud spend. So if that is your potential future, is there a better alternative to that? Well, if we think about building data services in the cloud, let's think about some of the building blocks you would start with, right? If you think about cloud native, what it's all about is microservices that are running in containers, orchestrated with Kubernetes that integrate into CI build loops or DevOps processes. You have a single plane in order to actually deploy and maintain and manage the whole life cycle of these services. But that's not necessarily how data looks like. What you need is that same operational paradigm that you use for stateless services for your data services as well. If we start at the first layer with developers, developers need modern APIs to interact with. They want to use natural things for them to use. They don't necessarily want to be concerned with all of the ins and outs of how a particular database structures its data. They want to go through an API gateway, and that API gateway can do metering, it can do control flow, it can act as a circuit breaker, and many other general services. Behind that gateway, you then have your data services. It could be traditional database services that provide tabular, graph, document, key value type of services. But increasingly, as applications are being modernized, streaming analytics and processing becomes a key part of that. You want to be able to separate producers from consumers and allow many consumers to consume those events that are being produced, so you can use it for disjointed connecting those applications and services through that data. You want to treat your data services in the same way that you do your stateless services. You want to run those through Kubernetes. That needs to sit on top of an object store so that you have persistence, and then you can survive the failure of particular racks or regions and zones, even entire whole areas. Finally, that needs to be able to be deployed on whatever infrastructure makes the most sense. It could be Azure and OpenShift on premise right now. It could be Azure or GCP in the future. You need the ability to put that data where it needs to be in order to solve the business problem. And that could be for locality reasons, but it could also be for regulatory and compliance reasons, ensuring that data set that's been manipulated stays within a territory or a region in order to conform with the local practices and the local laws. So that's what an idealized platform looks like. Why would you need a platform like this? Well, if you look at how microservices have been adopted, there's been a huge growth in API and microservice adoption within the organization. If you look at how Kubernetes is being used, the adoption is growing. It's like 48% of enterprises in 2020. By 2025, that's going to be 85%. So Kubernetes becomes that key piece of orchestration. Cloud, by 2023, it's going to account for 50% of all of that data that's being deployed. It's going to be in a cloud managed service. These are the reasons why this architecture starts to fit that long-term strategy of how cloud and cloud services will work. So at DataStax, we believe in delivering a true cloud native stack. What does that look like? Well, first of all, we want to ensure that developers have the right APIs, whether that's REST, GraphQL, document APIs. Our Stargate component, which is an open source component, acts as that API gateway that developers can use natural and native APIs and separate them from the detailed concerns of the data organization and the data manipulation of the database. We can plug in different backends into Stargate. The ones that are available right now are for Apache Cassandra and Apache Pulsar. How does that help you? Well, you've now got a way to natively do graph data, tabular data, document data, key value data, all in a single platform. You've got the ability to utilize streaming using Pulsar, so you've got all of those characteristics that people have come to expect from Cassandra of the infinite scalability and zero downtime across all of these tiers of service in the platform. We fundamentally believe Kubernetes is the way to orchestrate any service in the cloud, whether that's in your private cloud, whether it's in the public cloud. Kubernetes becomes that API of choice for doing provisioning, for doing scale in, scale out, and other administrative tasks. Underneath Kubernetes, we are doing an incredible amount of work to turn these architectures into serverless. So what's in it for you for serverless? Well, apart from the technology advantage of running serverless, separating compute from storage, what it really means is that you can start thinking about cloud economics in a completely different way. You can bend the TCO curve. Traditionally, you've thought about provisioning compute nodes, storage, networking, and then you'd size that for your peak capacity, which meant that there's a lot of idle capacity when you were not hitting those peaks, sitting there idle that you were still paying for. Serverless allows you to have consumption-based usage. You're now metered on your read and your write operations, and therefore combined with the Kubernetes and the ability to dynamically scale, that means that you've always got the capacity to consume more operations and simply get billed when you use those operations, not billed for the infrastructure that's sitting idle. We fundamentally believe that data services, managed data services run in this way, offer a huge economic benefit, as well as the technical advantage of being able to deal with any scalability demands that are made on that infrastructure. This is all managed on your behalf. You don't have to think about capacity planning and sizing in the way that you would have done traditionally. So what does this solution deliver to you? Well, it allows you to bend that TCO curve. It gives you the freedom of portability to run it on premise, to run it on hybrid, i.e. a mixture of on-premise and cloud. It allows you to run multi-cloud so that you can run the best of breed and take advantage of those services but have the right data in the right places. All of this helps accelerate the time to value, the ability to deliver new functionality to the business to solve new business problems without the friction of developers not having the right tools to do the job, or operators not having the ability to be able to manage and scale across all those different and disparate infrastructure types. At DataStax, what we're delivering is the open data stack for the future. It's Kubernetes based, it's developer ready with all the APIs they need, and it's cloud delivered. I want to thank you for your time, and I hope you found this interesting and insightful, and please feel free to reach out to me in contact. I'd love to talk to you about your usage of cloud and cloud native services at any time. Thank you.